What if I told you the most powerful AI humanity has ever created could lose at Snake? Today I'm putting Claude Opus 4.7, Anthropic's newest model, through the hardest coding challenge I've designed. And trust me, this isn't just hype. Head over to LM Arena's leaderboard right now, and you'll see Opus 4.7 sitting at the top in both chatbot and coding categories, voted by real users. Here's the challenge. Make Snake, but add an autopilot button where the AI plays perfectly. Sounds simple, right? Every modern AI can build a basic Snake game. But here's the twist: the autopilot has to play flawlessly. No trapping itself, no stupid moves. Just pure, calculated survival. According to benchmarks, Opus 4.7 scores about 10% better than its predecessor on SWE Bench Pro, a test for autonomous coding. But does that 10% actually matter in the real world? Let's see how it stacks up against the competition. Before testing Opus 4.7, I ran this exact challenge on other top AI models. Each model gets one shot, no debugging, no second chances. First, Gemini 3.1 Pro. Gemini wrote clean code using HTML, CSS, and JavaScript, easy to run in any browser. The UI was decent, and the autopilot logic forced the Snake to pick smart directions. But after just 7 apples, it trapped itself. Not great. Next, GPT-5.4. GPT took a different approach. The interface was extremely simple. No fancy visuals, no heavy graphics, just the core game. But interestingly, the logic worked better than Gemini's. Maybe it was a bit of luck, maybe the pathfinding was slightly smarter. Either way, the Snake managed to reach a score of 11 before eventually trapping itself. Better, but still far from perfect. Next up, DeepSeek 3.2, a Chinese model known for its strong programming abilities. DeepSeek delivered something impressive. The best UI so far, smooth visuals, polished interface, and overall the most visually appealing version of the game. And performance-wise, it was also the strongest competitor yet. The Snake managed to eat 17 apples before finally making a mistake. So what went wrong? The algorithm focused on finding a safe path to the apple, but it didn't properly account for long-term space management. Eventually, the Snake created a situation where there was simply no escape path left. In Snake, that's a classic failure mode. Next, Qwen 3 Coder. The graphics were actually pretty decent, but there was one huge problem. The game didn't work. When I pressed start, the apple kept changing position, but the Snake itself was completely frozen. With a quick debugging pass, the issue could probably be fixed, but remember the rule. Every AI gets only one attempt. So Qwen unfortunately scored 0. Then came Gemini 2.5, another Chinese model that has been getting a lot of attention recently. Gemini produced what might have been the coolest looking version of the game so far, a neon-style interface that honestly looked fantastic. But the logic controlling the Snake was terrible. The Snake moved inconsistently, made random decisions, and died after eating only 5 apples. Great design, terrible gameplay. Finally, I tested the previous version of Claude Opus 4.6. And this is where things got interesting. The Snake wasn't just moving randomly toward apples, it was making surprisingly intelligent decisions about direction and space. I expected maybe 30 or 40 points at best. Instead, the Snake kept going and going and going. It reached a score of 93. That's not just better than the other models, it's on an entirely different level. So if Opus 4.6 already performs like this, what about Opus 4.7? According to Anthropic, the new model performs about 10% better on coding benchmarks like SWE Bench Pro. The company also claims the model is better at handling complex projects, reviewing its own work, and reducing mistakes. So I gave it the same challenge. Make Snake with an autopilot AI that plays the game. And the solution it produced surprised me. Instead of using a simple pathfinding strategy like the other models, Opus 4.7 implemented something called a Hamiltonian cycle. In simple terms, it generated a predetermined zigzag path that visits every single square of the board exactly once, forming a continuous loop. The Snake simply follows this path. And mathematically, this guarantees something very powerful. The Snake will never collide with itself and will eventually fill the entire board. In other words, it can't lose. At first I ran the game at the default speed. Because of the long zigzag path, the Snake moved relatively slowly. After about 10 minutes it had reached a score of 58. but I wanted to see the full result faster. So I stopped the autopilot, intentionally killed the snake once, and asked the AI to modify the game speed to be 20 times faster. This time the result was clear. With the autopilot enabled, the snake followed its zigzag Hamiltonian path flawlessly, collecting apple after apple without a single mistake. No traps, no bad decisions. Eventually the snake filled the entire board, a total of 398 cells. A perfect game. And that might be the most interesting part of this experiment. The other models tried to be clever with reactive decision-making. Opus 4.7 solved the problem differently, by choosing a mathematically guaranteed strategy. Sometimes the smartest solution isn't more complex, it's just the right idea. Beyond coding, Opus 4.7 also brings several other improvements. The model can process extremely large contexts, up to 1 million tokens, meaning it can understand entire books or massive codebases at once. It also follows instructions more literally, meaning it's less likely to guess what you mean and more likely to execute exactly what you asked for. Vision capabilities have also improved significantly. The model can now analyze larger and more detailed images, up to around 2576 pixels in resolution, and it performs much better on long, multi-step tasks that require planning and consistency. But after all these tests, the real takeaway is clear. This wasn't just about winning a game. It was about how the AI approached the problem. While other models reacted to immediate threats, Opus 4.7 thought strategically. It didn't just play the game, it solved it. And if an AI can think this far ahead in a simple game like Snake, imagine what it can do with real-world problems.